All right. Absolute value and reciprocal functions. We're going to start with basic absolute value. I think reciprocal functions are 7.4 if I'm not mistaken. We'll do those coming up. Okay, now, it's really quite easy to do this stuff if you remember what I told you about piecewise functions. Do you remember this conversation, piecewise? Y equals, and then remember the big curly Q, and you split the two equations?
Oh, yeah.
You wrote one down just like it was, and then you took the other one and made it negative. Do you remember that? Do you remember that conversation we had when we were graphing this? Well, guess what we do here? Yeah, basically what we do is we solve the equation twice. That's all we do. We solve it one just like it is, and we solve one like it is negative. That's it. Okay, so let's do this. There's a reason I showed you that before, right? There's usually a method to my madness. Okay, so the first one is, just treat it like it is without the absolute values. Can you handle this? What do you do with the 3? What do you do with the negative 3? Add 3 to both sides, you end up with x equals 10. Now double check. We can see, right? 10 minus 3, 10 minus 3, yeah. 7. The absolute value of 7 is 7. So that one worked, right? Is that correct? Okay, now, do the exact same thing, but the only difference is instead of having the absolute value symbols, we're going to put brackets and make it negative. Oh, that's easy. There we go. So negative x minus 3 equals 7, right? Because the piecewise, right, is 2 components. One's positive, one's negative. What do you do with the negative now? So we end up with, well, okay, 2 ways of looking at this. You can distribute the negative, right? So you'd have a negative and a negative. We'd end up with a negative x, which is kind of a pain in the butt, right? Because then you have to divide by a negative number. So could you do it a different way? Is there other ways to think about this? Could we get rid of that negative? What do we do? Divide by a negative and divide by a negative. Could you do it that way?
Yeah.
Okay. I just want to make sure you understand because there's many ways of doing this. If you divide both sides by a negative, right, you end up with x minus 3 equals negative 7. That's one way to do it, right? Could you distribute and then move everything around also? Yeah, you could. Is that a little more work in this case? Yeah, it's a whole extra step. You have to decide how you want to do it, right? This one's easy to solve. What do you do with the negative 3? Move it to the other side. X equals negative 4. Okay, now, let's double check. Now, careful. Plug it back into the original equation. Negative 4 minus 3. Negative 7. The absolute value of negative 7 is? Does it work? Yeah, so in this case, is there 2 answers? Yeah, there is. There's 2 solutions in this case. And you can you test both them out? It's really quite easy to test them out. You always put it back in the original. Okay, so the solution... The solutions are, I guess I have is, but it should be, are x equals 10 or x equals negative 4, right? There's 2 possible solutions in this case. Is this always going to be the case that there's going to be 2 solutions?
No.
No. One of them could be, coming up, what's the word? Ah, there we go. Well, that stuff doesn't go away, right? The stuff we teach you just keeps coming back and back in different forms, right? What do you think? Can you handle that? That's basic, though. Are they going to get more complex?
Of course.
Okay, there we go. A little bit more difficult now. It's an absolute value equation. Let's kind of look at this holistically, which is like the big approach. How are we going to do this? Solve one with the original, without the absolute value, and solve one negative. Wow, that's tough, eh? How'd you put that away, please? Where are your books today?
Well, you know, I'm...
Oh, never mind. Not worth the explanation that I'm going to get.
Not here on Friday, but I
It's pencils over there. Go get one. Okay. Easy peasy. Watch. Take one, just get rid of the bracket. So 2x minus 5 equals 5 minus 3x. Can you solve that? Guys, if you can't solve that, you're probably in the wrong class. That's basic algebra. Yeah, it is. Now, what's the other thing you do? Take and instead of the absolute value, get rid of it and put in brackets and make it negative. Easy. So negative 2x minus 5 equals 5 minus 3x. Okay, see if you can solve those for me. Do those. Actually solve the algebra. Do the algebra for me. You should be able to do this. Just do the work, please. You need to do this, please, instead of talking. No, don't talk about the Walking Dead show, please. Just do the work. You're going to get two answers. You're going to get an answer on the left. You're going to get an answer on the right. You got to do this. Algebra.
I'll do it wrong and I have to erase all of it.
Just do it anyway. No, you got to try this. Math is one of those things you actually have to physically pick up your pencil and do. No, you didn't. Oh, you actually did. You got to do the next one now. Do this one. Distribute the negative. Guys, you got to be able to do that algebra. Seriously. Should end up with 2 and 0. Are they answers? Yeah, man. Let's try 0. Let's just try this one for a second. Try 0. What's 2 times 0? 0. So you end up with 0 minus 5, which is negative 5. Absolute value of negative 5 is 5. Okay, let's try. So the left side has to equal the right side. So the left side equals 5 right now. 3 times 0? 0. 5 minus 0? 5. So does 5 equal 5? So that is, yep, that's one of the answers. Let's test the other one. Now to do this, you would actually go back to the original equation, right? And you plug in the numbers. So here I'm going to write out the original equation. So the original equation is 2x minus 5 equals 5 minus 3x. And wherever we see an x, what are we going to replace it with? A 2. So 2 times 2 minus 5 equals 5 minus 3 times 2. Okay, what's 2 times 2? Minus 5. Absolute value is negative 1. 1. 3 times 2? 6. 5 minus 6? Negative 1. Is that true? Is 1 equal to negative 1? Oh my goodness. Okay, so what does that tell us about this x equals 2? It is a extraneous root. Extraneous. Why do you have to what? What did you ask? Extraneous. So in this case, how many solutions are there? 1. The biggest mistake you'll make is when you do this, you'll get the answers and you won't check. Well, if you put those down as the answers and you said the answer is 2 and 0, you'd lose marks because there is only one answer. It's 0. Okay, do the next one on your own. Right there. Do that one. One exactly the way it is without the absolute value, and the other one is put brackets to make it negative and solve.
Question.
Yeah.
Just where the...
Yes. Yep. I love this question because this is a prime example of not looking at the question before you start. You'll see in a minute. I have some of that cinnamon bun? It smells good. No, I'm just joking. I don't want to eat the hand lotion. Guys, you need to actually do these questions, please. Just around where the absolute values are. Yeah, that's what he just asked. Next to you. Maybe you should.
When we put the values back into the original equation, we can put the absolute value in both cases.
Yes, you have to, because it always goes back into the original. Right? In this case, the original is the absolute value. Okay. Hey, stop. Just stop what you're doing. Okay. So some of you are sitting there trying to do this question. And sometimes you have to stop and actually look at the question, because if you do that, you'll realize it's less work than you think. Do you remember discriminants, when we talked about discriminants? Wouldn't it be nice to know right off the hop, if you did the discriminant of a number and found out that it was negative, what did a negative discriminant tell you?
No roots.
There was no roots. Wouldn't you like to then stop and say, right, hey guys, there's no roots, why should I do the rest of this equation? Okay, but just think about that for a minute. Now I want to show you something. The reason I wanted you to try that is because there's a reason for trying it. So let's just talk about this for a sec. I'm going to rearrange this equation just for the start. So 3x minus 4, what can I do with that 12? Move it to the other side, it becomes 9 minus 12. Is that correct? Okay, so now look at this again. So 3x minus 4 equals, what's 9 minus 12? Okay, now stop. Think about that for a minute and tell me if there's something wrong with that.
Absolute value can't equal a negative.
Thank you. An absolute value can never equal a negative number. Is that true?
No.
That an absolute value can't equal a negative number? No, well, you can. There's no possible way in the math world that you can get a negative number after this. So is there any solution to this equation? Is there any number that you could plug into here that when you finally took the absolute value of it, you would end up with a negative number? No. So let's write something out here. So let's write it so you have it for your notes. That statement, this statement could never be true could never be true. So in other words, there is no solution. Right? So this is like the discriminant, right? Some of you realized that on that test way back, that when you actually check the discriminant, if you found out that was a negative, you'd know there's no solution. In this case, you're just looking and you realize, hey, wait a sec. I could never take the absolute value of a number and have it be negative, so I need to stop right there. Right? You could do the math behind it, then you'd end up with weird answers, right? You'd end up with no solution. They just don't work. Okay, now, this next one takes the entire page, this next example. The entire page. You'll see in a sec. It still doesn't matter, because look, back here on this other one, we got two answers, but one was extraneous. This one, if you possibly found answers, you realize neither of them work. There's no solution to this equation. You could actually solve it, but you'd find out you couldn't do it because of the negative. Okay, now look. Now look at that equation. It's really deceiving, this one, because it looks really simple.
I'm guessing it's not really simple though.
Could you actually guess and check this one?
Yeah. Really want to?
What number? Try a number.
4. 5.
We'll try something a little simpler.
4. 1. 4.
Let's try 1.
0.05.
What's 1 squared?
1.
What's 2 times 1? 2 times 1. 2. What's 1 minus 2? Negative 1. What's the opposite value of negative 1? Does 1 equal 1? Okay, so that's one of our solutions. It is in this case. Sometimes you'll see questions, but let's do this mathematically. You'll see in a second. Now, let's do our method for solving this. All we do is get rid of the opposite values and solve for x. What's the other way of doing it? Take the opposite values, replace them with brackets, and make it negative. Okay, so let's do the first method here. So x squared minus 2x equals 1. That's one method. The other one is this method here. Is that correct? Let's do the one on the right first. Easiest way, could you distribute that negative? Or could you just divide both sides by negative 1? Or times both sides by negative 1? It really doesn't matter. Basically, you're changing the signs, right? So either divide by negative 1, times by negative 1, or distribute. So what happens if we times everything by negative 1? X squared minus 2x equals negative 1. Now, we've seen these before. What do? Move the negative 1 to the other side, you end up with a lovely little trinomial. You better believe it's going to factor. Put your brackets down. What does that plus sign mean in front of the 1? The both sides are that same. And we look in front of the 2, it's a negative, so they're both negative. What times what gives us x squared? X and x. What are the only factors of 1? 1 and 1. When added together, do they give you 2? Oh, okay. Equals 0. Oh, well, this is kind of weird. So what's x in this case? X is 1 in this case. Didn't we just say that? Wasn't that one of the possible answers? Okay. It's getting there. So the right-hand side is pretty easy. Let's try the left-hand side. Yes.
Do we have to?
Yes, we do. All right, here we go. X squared minus 2x. What do we do with the positive 1? Move to the other one. Well, we end up with, isn't that the exact same trinomial we had over there?
Minus 1.
Ah, the other one over here was plus 1. In this case, it's minus 1. So what does that mean about the signs? They're different. Is there any possible way you could subtract 1 from 1 and get 2? No. Oh, boy.
So we have to use quadratic formula.
We have to use the quadratic formula. Okay, now, some of you haven't done the quadratic formula in a long time. First thing you do is do what? Even before you do that, what's A? What's A? 1. First off, is this in standard form? It has to be in standard form. B, negative 2. C, negative 1. Now what do? Write out the formula. Now, do you guys remember this? Hang on. X equals negative B plus or minus B squared 4AC all over 2A. Okay. But you don't even have to remember because you have the formula sheet, right?
Can we watch the video again?
Yeah, that's the formula. That's the formula sheet you get on the exam. Okay, let's fill in what we know. X equals, what's negative, what's B? So it's positive 2, right? Because negative becomes a positive. Plus or minus? Negative 2 squared minus 4, what's A? 1. What's C? Negative 1. All over 2 times what's A again? 1, okay. So X equals 2 plus or minus, what's negative 2 squared? 4. Negative 4 times negative 1. Positive 4, what's 4 plus 4? 8, so it's the square root of 8. All over, that's not an 8. This is quadratic formula. We spent how many weeks on this?
1.
Can't. Why not? You have to be able to divide that 2 out by both. But hang on a sec, though. Hang on. Keep. You're on the right track. Can you do something with that root of 8?
Or you can, put it into, like, the lesser form.
Well, what is the lesser form, then?
That would be
2 root of 2. Guys, factors of 8, 4 and 2, right? What's the square root of 4? 2. Okay, so that second part here can be reduced down to 2 plus or minus 2 root of 2 all over 2. Okay, now, Keaton, now what can you do? You can divide out the 2 because you can take it out of the front one and the back one. Now, Keaton, what do you think the answer to this? Let Keaton answer, please. Okay, you're wrong. No. Why is Keaton wrong? It's the most common mistake to make in this. You made it for me, thank you, but I knew you would. So, guys, what happened here? Those 2's don't cancel out. Guys, what is any number divided by itself?
1.
What's 2 divided by 2?
1.
So do we have to put that 1 in there? Yes, we do. We don't normally do that when we're reducing other stuff, but that 1 has to be in there. Now, does it matter if we put it over the 1? No, we don't need that, right? That doesn't have to be over 1. But that will be the most common mistake you make. You'll forget about that 1 in the front. Yes, but it's not in simplified form. Because you always have to put it in simplified form. That's the rule of math.
Yeah.
We just did. And when you put it, when you solve it, you always have to put it in.
That did take the full page.
Oh, we're not done yet.
Oh, yay.
Here's the question. Does this satisfy the original equation?
Nope.
Okay, equation didn't fit on there. Let me fix that. Sorry.
I'm gonna say yes, because
Hey, that's the question. Hey. We know one of the answers is 1 already, right? We could actually do that. Remember, we did that in our head.
yes.
Is this one of the possible answers? We don't know. Now, let's try. Now, basically, how many answers are right here? There's 2. Let's try x equals 1 plus root of 2. Let's try this. Okay, we're going to try it. Now, this is where the math gets a little bit weird, but you should see some patterns right away. Okay? So to test this, do we have to plug it into the original equation?
Yep.
Yes, we do. So we need to write down the original equation. It's always a good idea to do that first. Don't just try to write the next line. Always write down the original equation. So the original equation is as follows. What is the original equation? Absolute value of x squared minus 2x equals 1. Okay, there it is. Okay, so what's x in this case? 1 plus root of 2. Okay, so this is where it gets kind of weird looking. So we have, now what does that mean, x squared? X is 1 plus root of 2, and we're squaring it. What does that basically mean? Do you have 2 of them? Do you have 2 binomials? 1 plus root of 2 times 1 plus root of 2? Should I write that out? Would that make it easier for me? Yeah, sure, why not? So basically what I'm saying is 1 plus root of 2 times 1 plus root of 2. Isn't that x squared? Yeah, we take whatever x is and we square. That's what it means. Minus 2 times what's x again? 1 plus root of 2. Oh, goodness. Equals 1. Looks complicated, doesn't it? But have we done foiling with radicals before? Yeah, we did them, right? The nice ones where they were different to squares, weren't they nice? Because the center terms, remember, they canceled out. This one's not going to, right? We're going to actually have to FOIL this. But you can handle this. This is stuff we did when we did radicals and we did FOIL. No, it's not. Okay. Okay, so let's do this. So we're going to do FOIL. First, outside, inside, last. What's 1 times 1? Not helpful. 1 times root of 2. Root of 2. Root of 2 times 1. Root of 2. What's root of 2? And please do not say root of 4 when I ask this question. What is root of 2 plus root of 2? 2 root of 2. Thank you. Look, I'll write it out long ways then. We did the first, right? There's first. Now we're doing this. What is 1 times root of 2? Root of 2. Then inside, root of 2 times 1. Root of 2. You treat them exactly the same. What if I said, what's x plus x? 2x. What is root of 2 plus root of 2? 2 root of 2. What? We times the first part. We times 1 times root of 2. That's root of 2. Then we times 2. Look, there's pluses in here. This is basic FOIL. No. So what's root of 2 plus root of 2 is 2 root of 2. Okay, I'm getting rid of that and I'm putting my 2 root of 2 back in since you understand that now. Plus 2 root of 2. Okay, now, last part. This is the one that'll throw you also. Root of 2 times root of 2. This is times this time.
No, that's 2.
No, I didn't add them this time. What's root of 2 times root of 2 is root of 4, which is 2. That's the first one. Now what do we do with this guy? We just do straight distribution. So minus 2 minus 2 root of 2. Is that correct? Okay. Yeah, well, it will, hopefully. Some of you are going to have trouble getting past that step.
A lot of us.
That's just basic FOIL.
Basic.
Whatever. So let's do a kindergarten.
Guys.
Can you do that?
Guys, you learned FOIL a long time ago. The rules do not change. Like he was trying to multiply back there, but there is no multiplication, right? It's straight addition, those center terms, right?
I'm stupid.
No. Okay, now watch. Guys, this is really nice in this case. 2 root of 2 minus 2 root of 2. What happens to those? They're gone. 2 minus 2, what happens to those? They're gone. What are you left with? The absolute value of 1. What's the absolute value of 1?
2.
Again, not helpful. Is that true? Is that one of our solutions? Okay, now watch. Now, we tested 1 plus root of 2. Let's see how smart you are. Let's see if we can do this mentally. 1 minus root of 2. Okay, so think about this for a minute. So instead, guys, back up here. Instead of 1 plus root of 2, we're going to have 1 minus root of 2. Is this one going to change?
No.
Is this one going to change? It's going to become negative. Is this one going to change? No, because the negative times the negative is still a positive. So the only one that's going to change is the 2 root of 2. It's going to be negative. Okay, let's try this over here. Is the negative 2 going to change? No. But this one, since it was positive, is now a negative. What's the negative times the negative? Positive. So the only 2 that are going to change are these ones right here. Is that correct? This one's going to be negative. This one's going to be positive. So they still cancel? So we still going to end up with 1 equals 1? Yeah. Could you, if you wanted to, put it into the equation 1 minus root of 2 and do all the work?
Yeah.
Yes, you can. But if you can think logically, right, and think mentally, like mental math, you can do that. Why do you think we practice mental math?
So what you're saying is this is right? This is right.
Yes, you were right at the start. You were the only one in the class that assumed it was right. Okay, so hey guys, what are our solutions? X could be 1 or 1 plus or minus root of 2. Both of those. All 3 are possible. 3 are possible. Sorry, what?
What if it's going to x equals 1, but we get that?
If what, sorry?
If we don't write x equals 1.
X equals... Oh, no, you can just have 1 or 1 root of 2. That's fine. All right, here we go. Now, here's a tricky one. This is the last, I think this is the last one, isn't it?
I don't know.
These really, context of these and the basic things of this, they're really not that difficult, right? It's just you might get lost in the steps. Is that correct? Okay, so let's just look at the next one and kind of, before we even get going, let's just look at what we're going to do.
A lot of work.
Nah, not really in this case, because these ones actually work out quite nice. You're going to approach this two different ways. One way is to get rid of the absolute value and just solve. The other way is to get rid of the absolute value and replace them with brackets and make it negative and then solve. That's it. When you finally solve, there's a couple ways of solving it. Some of them might be factoring. Worst comes to worst, you might have to use the quadratic formula. And then the last thing you're going to do is you're always going to test to see if your answers are correct.
Yeah.
You got that? That's kind of the big thing, right? This is like a big question. This is a great test question.
No.
In fact, I think I even put this one on the test at one time.
No.
So that's good.
So that's a good thing.
I failed the last question.
No.
I think you should make a test of easier math test. That one's pretty
Blake,
hard.
if I put the bar on the ground,
I step over it.
right.
Don't trip on it. Probably not.
I'm trying to prepare you for grade 12 pre-cal. I don't want you to be scared of grade 12 pre-cal, but if you are not putting in at least half an hour to an hour a night of work, you will struggle with grade 12 pre-cal. There are people in Mr. McLaughlin's class that are there at every lunch hour working on pre-cal. No, they're actually really smart because they're there getting help.
So basically, no life.
Yeah.
An hour of night. Wow, that's no life. I help them. No, if you're taking pre-cal in the major sciences, you shouldn't be working. You have to have a job in high school, okay?
You don't have to. You can get off the chair.
Have you seen what he wears, though? That's not really spoiling. Okay, let's do this. Try one. Here we go. Let's do this one. This one's easy. I got a bunch of junk on the board. Hey, I got a bunch of junk on the board. What do I do?
Get rid of it.
Yes, but how do I get rid of it? Yes, but how do we solve it? That's the point I'm trying to get across here. Put it in standard form. That's a good option. Put it in standard form. So bring everything to one side and make it equal to 0. So let's bring everything over. Well, actually, what direction should I go with this one? Should I bring everything to the right or everything to the left? If I bring it all to the right, do I have to change the x squared at all? No, I don't. So let's bring it to the right in this case. So we're going to end up being 0 here. X squared doesn't change. This positive x moves it over to the other side, it becomes negative. So negative 11x. Move the negative 10 over there, it becomes positive. Okay, so there we go. What?
If you were to move it the other way, would it keep it the same?
It would, but then you'd end up with a negative x squared, and you'd have to divide out negative. Right? It's an extra step.
So we could practice it.
Go right ahead, do it. Okay. Guess what? This factor, you see right away it factors. The sign in front of the 10 is positive, which means both the signs are the same. We look in front of the 11, it's negative, so they're both negative. X, what times what gives us x squared? X and x. What two factors of 10, when added together, give you 11? 10 and 1. So in this case, is it 2 and 5? No, it's actually 10 and 11, 10 and 1. Wow, that's surprising. Well, we haven't seen one like that in a while, right? They've normally been the ones in the middle. What's x in this case? You make them both equal to 0. So x in this case is 10 or 1. Well, that's easy. Okay, let's do this again. Now, but what? So how do I write this out negative? What do I do? Let me move this. Let me move this negative one over. It's kind of in my way. So we put this here, negative x minus 10. Oops. Sorry, that's supposed to be a round bracket. Guys, come on, please. Okay. Okay, so all we do, guys, is we get rid of the opposite values, put regular brackets around it, and turn it into a negative, right? Do you understand why we're doing this from the piecewise when I showed you this? Okay, here's the thing. You don't like it. Do you even really have to understand it? No. Is it just a set of rules? Yeah, and something I learned a long time ago when I was in math. Sometimes you really actually don't have to understand a concept to be able to do it, right? Do you have to understand the origins and where a Pythagorean theorem comes from? No. Is it just a set of rules? Yes. Sometimes you have to do that because you will understand it as you start working through it. All of a sudden, you've done this before, all of a sudden, when something clicks, you understand it, right? Have you ever had that experience?
Oh my God.
It's like an aha moment or a eureka moment, right? Okay, so let's do this. Let's distribute this. Okay, what do we get? Negative x plus 10 equals x squared minus 10x. Now what do? Put it into standard form. So move everything onto one side. Now where do you want to move all this stuff again? You want to move it to the right because then we end up with a positive x squared. Beautiful. Good way of thinking about it. So 0 equals, our x squared still there. The negative x when it moves over becomes positive. So negative 10x plus x is negative 9x. And the 10 moves over becomes negative 10. Okay, so let's try to factor this guy into two binomials. The negative in front of the 10 means the signs are different. What times what gives us x squared? X and x. Two factors of 10 that when subtracted give you 9. 10 and 1 or 1 and 10, doesn't matter. And the signs, it needs to be negative because it's the larger of the two in that one. Oh, wow, this one was actually really quite easy to solve, wasn't it? X is 10 or negative 1. Well, that's weird. So the possible answers could be 10 or plus or minus 1. Right? We have 10 twice, so we only need to use it once, right? Which one of those is the answer? Could they all be the answers? Could none of them be the answers? Could maybe one or two or whatever be the answers?
None of us be the answers.
Yeah, I just said that. So then, what do you put? No solution.
What? Maybe solve for nothing.
Okay, let's test them out. Now, as you get faster with these, you'll understand that you can actually solve them pretty dang quick. Let's try this one. X equals 1. Let's try this. So what's the original equation? What is it? X minus 10 equals x squared minus 10x. Okay, here we go. We're going to try to see if 1 is a possible answer. So 1 minus 10 equals 1 squared minus 10 times 1. Once you get to this step, you could actually probably start doing a lot of this in your head. What's 1 minus 10? Negative 9. Absolute value of negative 9. Oh, here, let's write it out just so we have it. 1 minus 10 is negative 9. Well, can we stop right there? Why can we stop right there? Is there any way you can take an absolute value of a number and get a negative? Is that possible? No. So what does that tell us about x equals 1? 1 does not work. It is, so this, hang on, let's put a little note here. Cannot work. So 1 is extraneous. Oops, if I could spell extraneous, that would help. Hang on. Okay, now this is where you start using your mental math skills. So 1 did not work. Let's try negative 1. Negative 1 minus 10. Negative what? Negative 1 minus 10 is negative 11. Absolute value of negative 11 is 11. Okay. Negative 1 squared is still positive 1. Negative 1 times negative 10 is plus 10. 1 plus 10 is 11. So does negative 1 work? Yeah. Because you cannot ever take the absolute value of a number and get a negative. Right, 9 equals negative 9, no dice, right, it doesn't equal, right? So your next line back here would have been 9 equals negative 9. No, that doesn't work, right, it doesn't work, so it's not equal. So negative 1 works, let's try. It does work. 11 equals 11. Let's try 10. 10 minus 10.
0.
0, absolute value 0.
0.
Yeah, 0, it's the distance from 0. 10 squared. 10 squared. 100 minus 10 times 10. 100. What's 100 minus 100? 0. Does 0 equal 0? Okay, so in this case,
10 and negative 1 work.
so solutions are x equals 10 or negative 1. Does positive 1 work? No, because it's extraneous. That makes sense? Okay, hang on. Big picture.
It was really big picture.
Take your absolute value. Get rid of the brackets. Actually, before that, hang on. Look at the absolute value. Maybe look at it and decide whether or not there's the possibility that there might not be an answer. So, for instance, if you move the other junk to the other side and it says it has to equal a negative number, is that possible? No, remember that? We did that example back there. Okay, secondly, then solve. Make one without the brackets and just solve. Make one with the brackets and make it negative and solve. How you solve the equation could be one of many ways. Algebra, solve for x. Factor it into two binomials, and if that doesn't work, then you go to quadratic formula. Then, once you finally have your solutions, then what do you have to do? You have to test them. Is that a lot of steps?
Yeah.
Yes. You have 20 minutes today and all of class tomorrow to work on this. So please start today. Okay, you got that? Good.